next topic is energy storage systems. Energy storage systems. So as of now we have seen about various renewable energy resources. I mean how to grab energy from various resources have been discussed, and now we'll see how to store that energy, because we cannot utilize the entire energy generated, and also we cannot generate energy continuously from renewable energy resources most often, like solar energy, wind energy. The generation time is limited from morning to evening, or whenever that wind speed is sufficient. So these are the limitations. So we need some methods to store the energy generated, right? So the most effective method of storing energy is grid energy storage. So this stores electrical energy in bulk quantities, like megawatts, gigawatts, even thousands of gigawatts of power can be stored in grid. So what is that grid? What do you mean by that? Electric grid అంటే ఏంటండి? గ్రిడ్ ఫెయిల్ అయింది అంటారు, గ్రిడ్ అప్లింక్ చేశారంటారు, ఇంకేమో. వాట్ ఈస్ దట్ గ్రిడ్? Grid is a simple network of wires. Just a network of wires that connects energy generation systems, energy transmission and distribution systems. It connects all the three components of electrical energy. So power generation systems, power transmission systems and distribution systems. So a simple network of wires, that's all. So whatever energy generated, electrical energy generated will be simply roaming in the wires. Okay. So what is the problem with grid? When you connect renewable energy resources. So ఈ renewable energy resources grid కి కనెక్ట్ చేయడానికి మేజర్ ప్రాబ్లం ఏంటి అంటే grid fails when there is a huge power fluctuations. ఓకే, మనకి వెరీ రేర్గా వినుంటాం ఈ గ్రిడ్ ఫెయిల్ అయింది, మనకు 2-3 రోజులు పవర్ రాని రోజులు వెరీ రేర్గా జరుగుతూ ఉంటాయి. ఇష్యూ ఏంటంటే when there is a huge fluctuation in power, grid fails. So మనం ఈ రెన్యూవల్ ఎనర్జీ రిసోర్సెస్ తీసుకుంటే లైక్ సోలార్ ఎనర్జీ, విండ్ ఎనర్జీ, దే హ్యావ్ లిమిటెడ్ టైమ్ ఆఫ్ జనరేషన్. సో మార్నింగ్ టు ఈవినింగ్, లెట్స్ సే సోలార్ ఎనర్జీ, బై ఈవినింగ్ దట్ పవర్ జనరేషన్ స్టాప్స్. సో యూ కెనాట్ కనెక్ట్ దోస్ renewable energy resources to grid directly. So simple rooftop systems can be connected because they are of very small power. Whereas if you connect a 1 gigawatt plant or 1 megawatt plant to directly to grid, it fails by evening. That is a major problem. So to overcome that problem, India has initiated a great initiative. It is One World, One Sun and One Grid. One World, One Sun and One Grid. So this initiation was proposed by India. So it is basically a renewable energy grid. So if we connect all the renewable energy resources throughout the earth, so let's say all solar panels are connected to single grid around the earth, then what happens? The power generation will be continuous for 24 hours. So if sun sets on one end of the world, other end sun rises. So power generation will be continuous for 24 hours. So the better idea to store this renewable energy in grid is to connect all the resources to a single grid. Right? So this is a proposal initiative in India, and right now from Australia to these southeastern countries, South Asia, India, Middle East, up to this portion, all lines are connected. Okay, the project completed till this level. Europe and African continent, this work is in progress. Now the line entered into African continent and Europe. So further it has to go through South Africa and North America. So once that is also over, entire world is connected to a single grid, all renewable energy resources. So the advantage is everybody will have connectivity and control, so that all renewable energy resources now can be stored in bulk quantities, like thousands of gigawatts of power can be stored directly on a grid. So because this is the major requirement to run any industry or to run any heavy machinery, we require huge amounts of power, and ordinary batteries cannot be sufficient. Right? You cannot run an industry using a battery. So for that purpose we require a grid. Okay, so this is the primary energy storage system for renewable energy resources, and it is proposed by India. Okay, so next one is mechanical energy storage. So in this, when you have sufficient energy, you will convert it into mechanical energy, mechanical work. So simple one possibility that we have seen already is pumped storage hydroelectricity. Pumped storage hydroelectricity. So when you have sufficient power or solar energy, you will pump water to higher altitudes. So water from a reservoir will be pumped to higher altitudes, and when you need energy, you will run the water downwards and run your turbines. That is the simplest mechanism of storing this solar energy. I mean, when you have no resources to connect to grid or to batteries, you can use this one possibility. Pumping the water to higher altitudes whenever you have energy, and run it backwards to downwards when you need energy. Pumped storage hydroelectricity. Next one is gravitational energy. So you will be lifting heavy objects when you have sufficient energy, and you will drop it downwards to run your turbines whenever you need it. So ఏం చేస్తారంటే మనకి ఎనర్జీ ఉన్నప్పుడు హెవీ స్టోన్స్ పైకి లిఫ్ట్ చేస్తారు. అండ్ అది కిందకు వచ్చేటప్పుడు మనకు కావాల్సిన టర్బైన్స్ ఏవో రొటేట్ అవుతుంటే మనకు కావాల్సిన ఎనర్జీ జనరేట్ అవుతుంది. ఐ మీన్ ఈవెన్ యూ హ్యావ్ అ గ్రావిటీ క్లాక్ ఇన్ అవర్ మ్యూజియం. చూసారా అది? దట్ ఈస్ అ గ్రావిటీ క్లాక్. ఒక హెవీ వెయిట్ ఉంటుంది, జస్ట్ హ్యావ్ టు లిఫ్ట్ ఇట్ అప్ and by the time it reaches the ground, the clock runs for 1 week. So ఆ వెయిట్ ఇలా కొంచెం కొంచెం కిందకు వచ్చేలోపు 1 week పాటు క్లాక్ రన్ అవుతుంది. సో దిస్ కైండ్ ఆఫ్ ఎనర్జీ స్టోరేజ్, gravitational energy storage. Okay, another type of energy is quite opposite to that, bio and rail energy. So this is similar to that. Instead of lifting heavy weights, we'll be lifting heavy train carriages. ఈ ట్రైన్ కంపార్ట్మెంట్స్లో హెవీ వెయిట్స్ పెట్టేసి ఒక హైట్ ఒక హిల్ మీదకి తీసుకెళ్ళిపోతారు. వెన్ హ్యావ్ ఎనర్జీ విల్ బీ పుల్లింగ్ అప్ ద హెవీ వెయిట్ ఆన్ ఏ రైల్వే ట్రాక్, అండ్ వెన్ ఇట్ కమ్స్ బ్యాక్ యూ కెన్ రీజనరేట్ ద ఎనర్జీ స్టోర్, రైల్ ఎనర్జీ స్టోరేజ్. And opposite to that is buoyant energy storage. Buoyant energy storage ఏంటంటే instead of lifting an object, heavy object against gravity, we will be pushing a lighter object into water. ఒక బెలూన్ తీసుకోండి, fill it with air and push it into water. So it requires some additional energy. So when you have sufficient energy, you push the balloon into water, and when you need energy back, the balloon will be lifted up and it runs the turbines, whatever way you need. So it is simply opposite to gravitational energy storage, buoyant energy. And next method is compressed air. Compressed air energy storage. So when you have sufficient energy, you compress air, and when you need it back, it will be released, and that high pressure air will run the turbine. So this has two different methods of storing. One is keeping the volume constant and raising the pressure. So we'll be using a cylinder. So take a air cylinder and compress it. So volume remains constant and pressure increases as and when you try to compress it. So what happens? The problem with this system is keeping volume constant and raising the pressure. When you try to convert it back to energy, back to electricity, this pressure difference makes a effect. ఏమవుతుందండి, హై ప్రెషర్ ఉన్నప్పుడు ఆ టర్బైన్ అనేది ఫాస్ట్గా రన్ అవుతుంది. టర్బైన్ రన్స్ ఫాస్టర్ వెన్ ప్రెషర్ ఈజ్ సఫిషియెంట్లీ హై, అండ్ వెన్ ప్రెషర్ రెడ్యూసెస్ టర్బైన్ రన్స్ స్లో. సో యూ కెనాట్ కనెక్ట్ ఇట్ టు ఏ కంటిన్యూస్లీ రన్నింగ్ మెషిన్. అర్థమవుతుందా? మీరు దాన్ని ఒక ఇండస్ట్రీలో ఒక మెషిన్కి కనెక్ట్ చేశారనుకోండి, ఏమవుతుంది, ప్రెషర్ హై అయినప్పుడు ఫాస్ట్గా రన్ అవుతుంది, ప్రెషర్ తగ్గిపోయి డౌన్ అయిపోయినప్పుడు స్లో అయిపోతుంది. సో ఇలాంటి సిస్టమ్స్ మనకి కన్వీనియంట్గా వర్కౌట్ అవుతుంది. సో అనదర్ ఆల్టర్నేటివ్ ఈజ్ you keep the pressure constant and rise the volume. So for that you require air bags. Just like a balloon, volume increases if you pump air into that. Air bags or balloons will do the job. So there the pressure remains constant. So the machines run at constant speed. When you try to convert back into electricity, all the machines will run at constant speed because the pressure remains constant. So we'll be rising just the volume. But this machinery requires huge amount of space. Right? Whatever energy, I mean, you need to rise the volume continuously, right? So that requires huge amount of space. So there is a trading between this volume and pressure. So depending on our energy storage capacity and energy requirements will be using either of these two systems. Next one, another kind of mechanical energy storage system is flywheel energy storage. What is that flywheel? So it is simply a heavy wheel. When you have sufficient energy, you will be storing it in the form of rotational kinetic energy. Half I omega square. So the energy is stored in the form of rotational kinetic energy. The advantage with this is huge amounts of energy can be stored, because when the wheel rotates at 10 rotations per second, if you have sufficient energy, you make it 15 rotations per second. And if you have even more energy, make it 20 rotations per second. So like that, rotation speed increases when you have energy, and when you try to get it back, that speed reduces. Right? So that is the simplest mechanism with high energy density. You can store huge amounts of energy using this flywheel storage. How long that wheel runs? If ఒక వీల్ ఇచ్చారు, దాన్ని తిప్పేసి వదిలేశారు, అది ఎంతసేపు ఉంటుందండి తిరుగుతూ? ఎంతసేపు ఉంటుంది? Few seconds to a few minutes. Whereas if you use magnetic bearings in vacuum, ఏం చేస్తారు? మ్యాగ్నెటిక్ బేరింగ్స్ని వాడతారు. మ్యాగ్నెటిక్ బేరింగ్స్ అంటే ఏంటంటే, నార్మల్ బేరింగ్స్లో ఏముంటాయి? there will be two wheels and in between them there will be small balls to reduce the friction. So ఇలా రెండు wheels ఉంటాయి, ఈ మధ్యలో balls ఉంటాయి. So instead of that, we'll be using magnets. So if you keep both north and north, what happens? They get repelled. If they won't touch, then they run smoothly. సో ఇలాంటి మ్యాగ్నెటిక్ బేరింగ్స్ యూజ్ చేసి ఈ మొత్తం సెటప్ని మనం వ్యాక్యూమ్లో సెట్ చేసేస్తే ఏమవుతుందంటే, ఇఫ్ యూ జస్ట్ రొటేట్ ఇట్ అండ్ లీవ్ ఇట్, ఇట్ రన్స్ ఫర్ ఎవర్. సో ఇలాంటి సిస్టమ్స్ ఎస్పెషల్లీ ఆర్ యూజ్డ్ ఇన్ స్పేస్ ట్రావెల్. సో నాసా has developed one such flywheel energy storage system, and that is running for the past 10 years, more than 10 years. అదవుతుందంటే దానికి ఒకసారి ఎనర్జీ వదిలేస్తే ఇట్ ఈస్ రన్నింగ్ ఫర్ మోర్ దాన్ 10 years. సో అక్కడ వాడుతుందంటే మ్యాగ్నెటిక్ బేరింగ్స్ ఇన్ వాక్యూమ్. సో ఇంతకీ ఎందుకు వై స్పేస్ ట్రావెల్ రిక్వైర్స్ దిస్ కైండ్ ఆఫ్ ఎనర్జీ స్టోరేజ్? సింపుల్ అంటే సోలార్ వాడుకోవచ్చు కదా. Yeah. So when you reach the boundaries of solar system, even sun looks like a star. So మనం నైట్ టైం స్టార్స్ పెట్టి సోలార్ ప్యానల్ పనిచేస్తుందంటే ఇట్ విల్ నాట్ వర్క్ విత్ లైట్స్ ఫ్రమ్ స్టార్. So we have to look for alternative energy storage. So even if you take nuclear energy, it has a limitation. So other alternative is this mechanical energy, flywheel energy storage. So when you have energy, you will be rotating the wheel, and when you need it, you will grab it back. So that is most effective way. Another is Stratosolar balloons. So ఇక్కడ ఏం చేస్తారు, the entire balloon is made up of solar panels and it carries heavy weights. The entire balloon is made up of solar panels, so it generates electricity, and that generated electricity is utilized to rise the balloon up. So balloon carries heavy weights. What happens when you need energy? You just drop the stone downwards, just like this. Gravitational energy storage. Instead of lifting the object using ropes, we will be using balloons. Okay, so the balloon rises up and reaches up to stratosphere. So it is the second layer. Troposphere, stratosphere. The balloons reach up to stratosphere. So from there, if you drop a stone, it is a huge amount of energy. Right? So these are the various types of mechanical energy storage systems. Okay. Next one is thermal energy storage. So whatever heat or whatever energy generated, like solar energy, is now converted to thermal energy for storing. So this thermal energy is basically of two types. One is latent heat, another is specific heat, or it is also called sensible heat. So what are the possibilities? When you give heat energy to the system, either it will rise its temperature or it will cause a state change. So the given energy will be utilized to rise the temperature, one possibility. Another possibility is its temperature increase. So when the given energy is utilized to state change, it is called latent heat. So it will not affect any temperature. Temperature lo marpu aithe raadu. Entire energy will be utilized to break the bonds. So it creates a state change, but no rise in temperature. దాన్ని latent heat అన్నారు. Sensible heat అంటే ఏంటంటే you can sense it using a thermometer. So whatever heat supplied will be utilized to rise the temperature. So these are the two types of energy storage systems. So when you have sufficient energy, you will try to convert or you will try to change the state of the system. Like it is one possibility is molten salt. So when you rise the temperature of salt, it turns into liquid. Okay, you can store huge amounts of energy. Okay, and when you need it, you will grab the heat and run turbines, just like in your thermal power stations. Thermal power stations ఏం చేస్తారంటే, the temperature will be utilized to boil water. It generates steam, and steam engines will be working as turbines. అర్థమవుతుందా? సో థర్మల్ ఎనర్జీ మళ్ళీ గ్రాబ్ ఎట్లా చేసుకోవాలి, రిటర్న్ ఎట్లా ఎలక్ట్రిసిటీగా కన్వర్ట్ చేయాలి. విల్ బి యూజింగ్ దట్ థర్మల్ ఎనర్జీ టు బాయిల్ వాటర్, అండ్ ద స్టీమ్ ఈజ్ యూటిలైజ్డ్ టు రన్ ద టర్బైన్స్. Okay. So these are the two types of thermal energy storage systems. Next one is electrical energy storage. So here the electrical energy is stored as it is as a electric field. So best example is capacitors. So there are various types of capacitors like supercapacitors, hybrid capacitors. So ordinary capacitor, it takes a few seconds to a few minutes for charging, and even for discharging it takes usually the same time, a few seconds to a few minutes. So you cannot use those capacitors for even for in your cell phones. The problem is charge retention time is very low. Even if you charge it in a few seconds, the charge falls down in the same manner within the same span of time. So people have developed these supercapacitors which have, I mean, supercapacitors they have a little longer charging time. So they take 5 to 10 minutes for charging, and charge remains for 1 day, let's say 24 hours. So that is one possibility. And these hybrid capacitors, they have a hybrid combination of technology of batteries for charge retention and technology of capacitor for charging. So charge చేసేటప్పుడేమో కెపాసిటర్ లాగా క్విక్గా ఛార్జ్ అయిపోతుంది. సో కన్వెన్షనల్ ఇది ఒక సెకండ్, ఇది ఒక మినిట్ అయితే ఇది ఒక 10-15 minutes పడుతుంది. బట్ ఫర్ డిశ్చార్జింగ్ ఇట్ రిమైన్స్ ఫర్ ఆల్మోస్ట్ ఎ మంత్. మీరు ఛార్జ్ చేసి అలా పెట్టేస్తే అట్మోస్ట్ ఒక 1 month వరకు కూడా ఛార్జింగ్ అలా ఉంటుంది. They are called hybrid capacitors. So the energy is stored in the form of electrical energy, electric field, but it has a technology of both, it incorporates the technology of both batteries and capacitors. There are special charging circuits developed for these hybrid capacitors. Now everybody is turning into that. Even for electric vehicles, this is the best possible system. The only issue is these systems can be used only for daily energy usage. సో మీరు అలా స్టోర్ చేసేసి ఏదో వాల్ క్లాక్లో పెడదామంటే అయ్యే పని కాదు. ఏమవుతుందంటే వాల్ క్లాక్లో ఎట్లాగా మనం ఒకసారి బ్యాటరీ వేస్తే ట్రాన్స్ఫర్ అయ్యారు, రైట్? Whereas our cell phone, we charge it in the morning, by night it will be over, and again you have to recharge it, right? So that kind of where your energy requirements are on daily basis, we'll be using these hybrid capacitors, super capacitors, because the charge retention time is very low, like a few days to a few weeks, but they can be charged very quickly within a minute. Okay, right now even our electrical vehicles are able to charge up to 50% within 15 minutes. So main electrical vehicles drawback ఏంటంటే ఛార్జింగ్ స్టేషన్లో పెడితే మనకి పెట్రోల్ అంటే ఒక 1 minute ఫిల్ చేసుకొని వచ్చేయచ్చు. ఎలక్ట్రిక్ వెహికల్ 4-5 hours మీరు ఒక జర్నీ స్టార్ట్ చేశారు, మధ్యలో 4-5 hours బ్రేక్ తీసుకోండి, ఆ తర్వాత ట్రావెల్ చేయండి అంటే అదే పని కాదు. సో ఆల్టర్నేటివ్ ఏంటి, use these hybrid capacitors. Now EV electric vehicles are running at that, I mean they are using these hybrid capacitors so that charging time within 15 minutes they charge up to 50%, and within an hour it fully charges. So that's how the technology is developed. And other energy resources, energy storage systems ఇంకేమన్నాయండి? ఫోటోకెమికల్, superconducting energy storage. So here the energy is stored in the form of magnetic energy. ఏమవుతుందంటే సూపర్ కండక్టర్స్ అంటే ఏంటి? The conductors with zero resistance. So usually we require a battery to run the electrons or to drive the electrons in a wire. So మనం magnetic field ఎట్లా జనరేట్ చేస్తామంటే take a coil, connect it to a battery. When the electron runs in the coil, magnetic field will be generated, right? And when you remove the battery, magnetic field turns off, right? So to move the electrons in a wire, we require some driving force, and that's called electromotive force. We will be using batteries to drive the electrons in a wire, right? Alternatively, I mean, in the superconducting materials, the reason is because of resistance, the electrons once they start moving, they'll stop quickly because of the resistance. So if the resistance becomes zero, what happens? Once you just push the electron into the wire, it runs forever. Okay, so for that purpose we will be choosing these superconducting materials. When you reduce the temperature of the material to extremely low temperatures like 0.1 Kelvin to 10 Kelvins, means around minus 260, minus 270 degrees. At that low temperature, certain materials become superconducting. ఏమవుతుందంటే వాటి resistance becomes zero. So when you inject an electron into that wire, the electron runs forever. So we'll be using that technology to store electricity. And when you need it, you will get it back. Just like in a transformer. Transformer ఏమవుతుందంటే energy is stepped up or stepped down using magnetic field. So input energy is converted to magnetic field. It will be multiplied or divided using equal number of coils. So magnetic energy గా కన్వర్ట్ చేసి దాన్ని మళ్ళీ స్టెప్ అప్ స్టెప్ డౌన్ చేస్తున్నాం. Same way we will be storing in superconducting coils in the form of magnetic field. So మళ్ళీ మనకు కావాల్సినప్పుడు will be taking another coil near to it. So by induction the energy can be retrieved. Next one, chemical energy storage. So the best example is batteries. It is storing energy in batteries. So earlier lead acid battery, nickel cadmium battery, nickel metal hydride battery, there are various types of batteries that we are using now, and everything can be recharged. Okay, so now the technology now shifted to lithium ion batteries. So they have the only problem with batteries is they have charge cycles, limited charge cycles. If you charge the battery for 10,000 times or 1 lakh times, the battery fails. Okay, even in your cell phone batteries, if you charge it for 10,000 times, on average, battery fails. That is the lifetime of a battery. So if you charge it and remove the cable, charge it and remove the cable, its lifetime reduces. So it will be counted as one charge cycle. Once you connect the cable and remove it, it will be counted as one charge cycle. Even if you keep it for 1 minute or 1 hour, it will be counted as one charge cycle. So like that, every battery has a limited charge cycles count. So once that count is over, battery dead. So that is the problem with chemical energy storage. So alternative is better alternative as of now is lithium ion and lithium polymer batteries. So these lithium polymer batteries are now being used in EVs. Electrical vehicles are using these lithium polymer batteries. So conventional batteries, if they have 10,000 charge cycles, these lithium polymer batteries have 50,000 to 1 lakh charge cycles, almost 5 to 10 times count increases. So recent technology is lithium polymer batteries. Okay, and last one is photochemical energy storage. Here we have this one more thing I will discuss. Okay, so photochemical energy means whatever energy is stored in the form of it will be converted into light and then into energy. It will be converted into light and further into energy, just like photosynthesis. Photosynthesis lo em jarugundante, sunlight is utilized to develop food. It is utilized to create new bonds and new materials. Okay, so that's kind of photochemical energy storage. Will be converting available energy into light and further it will be utilized to generate food. So that's photochemical energy storage. And last one, this in the thermal energy storage, third system is ice energy storage. So this is a system developed for cold countries. So where you have snowfall. So snowfall వచ్చినప్పుడు వాటర్ని ఐస్గా కన్వర్ట్ చేసి స్టోర్ చేసేస్తారు. నైట్ టెంపరేచర్ వెరీ లో ఏం చేస్తారంటే వాటర్ తీసుకొని దాన్ని ఐస్గా కన్వర్ట్ చేసేసి స్టోర్ చేసేస్తారు. దాన్ని ఎట్లా వాడుకోవాలి, దాని నుంచి మళ్ళీ ఎలక్ట్రిసిటీ ఎట్లా జనరేట్ చేయాలి? హీట్ ఎనర్జీ అంటే మనము ఏదో స్టీమ్ జనరేట్ చేస్తాము, టర్బైన్స్ రన్ చేస్తాము, వ్యాలిడ్. వాట్ అబౌట్ ఐస్ ఎనర్జీ? హౌ టు రిట్రీవ్ ఇట్ బ్యాక్? So you might have come across this Carnot engine. Carnot engine విన్నారండి? ఎఫిషియన్సీ ఏంటిది? ఇదేనా? 1 - T1/T2 నా? T1/T. So to achieve 100% efficiency ఏం చేయాలి? ఒకసారి చూడండి, కార్నోట్ ఇంజిన్ ఎఫిషియన్సీ ఫార్ములా చెప్పండి నాకు. ఎఫిషియన్సీ ఆఫ్ కార్నోట్ ఇంజిన్. One minus అంటే ఏంటి, టీహెచ్ అంటే ఏంటి? కోల్డ్ ఎయిర్. ఓకే, దట్స్ వాట్ 1 minus T1 by T2. సో ఏమవుతుంది, if the cold reservoir maintains a temperature of 0 kelvins, 0 kelvin ఉన్నప్పుడు ఏమవుతుందండి, efficiency is 100%. But we cannot reach that 0 kelvin. So other alternative is to raise the hot reservoir temperature. సో దాంతో ఒక 100 200 ఉంటుంది. ఇది మనము ఒక 500 700 రీచ్ అయితే, సో దట్ డిఫరెన్స్ విల్ ఇంప్రూవ్ ద ఎఫిషియన్సీ. అంటే కదండి, TC is 0, efficiency is 100%. But TC is not 0, it will be around 200. So if pH is 400, what happens? This will become 1 by 2, so efficiency is 50%. Okay, so if pH is 2000, TC is 200, TH is 2000, what happens? It will be 90%. And then 1 by 10, 0.1. 1 minus 0.1 is 0.9, 90%. So, to improve the efficiency of this Carnot engine, either we have to increase the value of TH or we have to reduce the value of TC. So, if you store energy in the form of latent heat or specific heat or sensible heat, you will be using it to rise TH. Otherwise, if you store it in the form of ice energy, you will be using it to reduce TC. Cold and temperature maintain చేయడానికి మనం ice ని యూస్ చేసుకోవచ్చు. And that is available freely. Right? So, this is an alternative way of energy storage. I mean, utilized when especially in cold countries. Okay, so these are various energy storage systems developed for renewable energy resources. Okay, grid energy, this is most required. Other one is mechanical energy, different types of mechanical energy, thermal energy, electrical, superconducting, chemical, photochemical. That's all. Okay, next topic will see in the next session.